Part of what we do on the NVIDIA demo team is try to exercise every bit of NVIDIA technology to see that everything works well. So we came up with this concept of a rocket sled demo that would be utilizing PhysX to create a difficult physical simulation where every suspension component, every shock, every engine mount would actually work like it should, like it would in real life. We use CUDA to simulate particles, and we used PhysX to do debris and all sorts of other various things. You'll notice in the smoke that comes out from the back of the rocket, it's actually also physically simulated. We run a fluid simulation behind it. We're able to get kind of this vorticity and sort of fluid look out of these particles because we're actually physically simulating them. And we use that with SLI in stereo to sort of try to get every one of the NVIDIA technologies ironed out before the chip finally gets to market. Rocket Sled demo utilizes DirectX 11 for the terrain. It uses dynamic tessellation to create the terrain in the background. Tessellation allows us to use a low-resolution mesh, and a height map in this case, and dynamically sort of subdivide this mesh and create more detail only where it's necessary. Tessellation allows you to not only subdivide the environment, but also do kind of more interesting characters. It allows you to have smoother edges on faces, potentially have displacement maps to create sort of more vicious-looking creatures and things along those lines. We've used compute to simulate some of the debris particles. One of the things that we've done is to see how far we can push it. And there's a bridge that gets destroyed in the demo, and one of the things that we tried is, well, initially we started off with 10,000 sort of debris particles falling off the bridge. We said, well, what if we could push that to 100,000? And it still ran. It still used the same GPU to simulate them and to render them. We took that to 500,000 particles. We took that to 1 million, and at that point it looked so ridiculous because the number of particles generated was probably 10 times greater than the volume of the bridge itself. But we did it just to see that if it is possible, and it is in fact possible. I mean, it is potentially feasible to simulate and render millions of particles on the same GPU. A lot of the time when working on this demo, we actually found ourselves playing with it, far too much. Some of the things that you can control in the demo are thrust, brakes, and we have 4 forward boosters and a single reverse booster. And the goal is to get past the finish line and stop before falling off the end of the cliff. And if you are able to accomplish that, you'll actually post the time.